Regex is hard. How would I learn Regex if I could start all over again? They may seem difficult at first, but I believe that by the end of this video, you will be able to write your own custom regex. Regular expressions allow us to search for specific patterns of text. They are used for email validation, text extraction, and many other purposes. A regular expression allows you to specify the rules for the set of possible strings that you want to match. You can then ask questions such as, is there a match for this pattern inside this string? Don't worry if this pattern looks scary. I'm going to explain it in a moment. Let's start with the basic. Most characters and letters would match themselves. This means a text like hi would simply match any hi found in the given string. As you can see, the hi pattern matches every hi found within the string. If we decide to match letter I, then all the letter I found would match. The same goes for digits. Let's say 57. It matches all the occurrences of 57. There are some characters in Regex that have special meanings. This set of characters, also known as meta characters, will not match by default because they have special meanings. If I was to use any of these characters, you will see that it behaves unusual. The dot sign is matching every character in the string. I'm going to explain what each of them means later. The first meta characters we are going to explore are brackets. They are used to specify a set of characters you wish to match, A, B, C. This will match any of the characters A, B, or C. As you can see, any of the characters listed in the brackets is matched, A, C, and B. We can also use numbers 095, 05. It looks like we don't have 9 in the test string. Within a character set, we can use a dash to specify a range of characters. For instance, we can write A to M. This will match every characters from A to M. A to Z matches every lowercase characters from A to Z. If you notice, some uppercase letters are excluded. This is because Regex is case sensitive. This means lowercase a is not the same as uppercase A. If I was to write uppercase A to Z, this will match every uppercase letters from A to Z. If you want to match every characters from A to Z, regardless of their cases, then you can use A to Z and A to Z. As you can see, all the characters are highlighted. We can also use a range for numbers 0 to 9. This matches every numbers from 0 to 9. Let's say 0 to 4. Then it matches every number from 0 to 4. Here is a question. Can we specify ranges in a reverse order, C to A? We cannot do that. Pattern error. Character range is out of order. Let's write 4 to 0. This is not allowed. Remember I mentioned that all these characters are meta characters, meaning they have special meanings in Regex. But when used in brackets, they are denied their special meanings, except the backslash, which retains its special meaning. This means a $sign used inside brackets will still match a $sign because it has no special meaning when used in brackets. We can also use the dot sign. As you can see, we are able to match the dots. Alright friends, we mentioned that any of the characters listed in brackets is matched. For instance, this will match A, B, or D. If we intend to match all characters except A, B, or D, then we can introduce a caret as the first character of the set. Let's do that. As you can see, all the characters are matched except A, B, and D. Remember we mentioned that a caret is part of the meta characters, but when used inside brackets, it is denied its special meaning. If the caret appears elsewhere in the character set, it doesn't have the negation meaning. Let's do that. So this matches A or B or D or the caret sign. It only has a negation meaning if it appears at the start. The key takeaways from this section is that If a caret appears as the first character in a set, then it negates the set of characters after it. Also, all meta characters are denied their special meanings when found in brackets except the backslash. The next meta character is the backslash. From the previous lesson, we learned that this will match all uppercase letters from A to Z. This is the same as writing A, B, C, D, E, F and listing them up to Z. The same applies to numbers 0 to 9. This is the same as writing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But there is a short form for what we've written so far. The short form for 0 to 9 is \D. This will match any numeric digits. Remember that if you want to negate 0 to 9, you would have to put a caret as the first character. This matches all characters except 0 to 9. So the shortcut for that negation is to write \D uppercase, which is the opposite of the lowercase. Backslash followed by lowercase d matches all numeric digits. When it is uppercase D, it negates the previous meaning. Square brackets A to Z, and underscore. What you have here will match all word characters, including an underscore. The shortcut for this is to use \lowercase w. This matches all word characters, including an underscore. As usual, if you want to negate it, then you can use an uppercase letter, W. As you can see, this matches the characters that are not word characters. So the backslash followed by some set of defined characters in regex could mean a short form. The next function of a backslash is for escaping characters. If you've ever written code in any programming languages, you probably know what a backslash in a string means. It means escape character. It can be used to escape all the meta characters, so you can still match them in patterns. For instance, you may want to match an asterisk. If you just type asterisk, it shows that it is an invalid pattern because this does not conform to how an asterisk is used. So you can precede it with a backslash to remove its special meaning. As you can see, we are now able to match an asterisk, which is a meta character. Another capability of regex is that you can specify that a portion of regex must be repeated a certain number of times. The first meta character for repeating things is asterisk. The asterisk specifies that the previous character must be matched 0 or more times. When we type NE, we can see that it matches all occurrences of NE. Typing letter E again will match NEE. If we don't want to keep repeating the same character, we can simply use asterisk, which means the previous character can be matched 0 or more times. So this will match N, NE, NEE, and so on. This means letter E can occur 0 or more times. I hope you still remember that using any of the meta characters loses their special meaning when used in brackets, except the backslash. So when you surround this regex with brackets, the asterisk does not have any special meaning. This matches N or E or the asterisk symbol. As you can see, we have letter E, N, and also the asterisk symbol. The next quantifier is the plus sign. The plus sign ensures that the character before it matches 1 or more times. So this will match NE, and the E can be 1 or more times. That's why we are able to match the 2-letter E here. If we write NE, it is going to match because the E should be at least 1. If we intend to do an exact match for the preceding character, then we can put the number of times in curly braces. Let's put 2. This means the letter E must appear twice. Let's put 1 to see what happens. Great, we are able to match NE and NE. The next quantifier is a question mark. A question mark matches 0 on 1 repetition. This means we can match N alone and NE, N, NE, N, NE. Moving on, we have the pipe symbol. This will create a regular expression that will match either A or B. As you can see, every highlighted character is either A or B. Let's say we want to capture the first part of every phone number in the text string. We can write the regex as 081 or +234. Remember that the plus sign has a special meaning. We are going to use a backslash before the plus sign so that its special meaning is ignored. Now we are able to capture the first part of the phone numbers. Just like in most programming languages, we sometimes use parentheses to group things together. This current regex works, but using parentheses to group each part makes it easier if we need to apply some rules to a particular group. For instance, we can apply a quantifier to this part, so we can group it together by using parentheses. Now it is easier to apply a quantifier to this group. Let's say plus. The plus sign means one or more times. Let's write +234 +234. As you can see, we are able to match +234 two times. The caret symbol ensures that the following pattern starts at the very first character. For instance, this will only match the string high if high is at the beginning. As you can see, we have two matches, high, high. This high is not matched because it is not at the beginning. If I was to remove the caret in front of the pattern, it matches every high in the string high, high, high. Unlike the caret symbol, which matches the beginning of a string, the dollar sign ensures that the preceding pattern ends the string. So this pattern will only match high if high is at the end. As you can see, high is at the end of the line. If we write high there, it doesn't match. Now if we combine the caret and the dollar sign, it only matches high, which is the starting and the ending. There is no match because we don't have any high which is standing alone. Let's create one. As you can see, this is starting and this is ending. We have a match because it is the starting and the ending. Let's try another example. Apple. Let's write pineapple. Apple. So it doesn't match the apple in pineapple because it is not standing alone. If we intend to match apple which is ending, then we need to remove this. So we are able to match every occurrences of apple that are ending. Alright friends, the dot sign matches any character except a new line. As you can see, we are able to match every character except this new line. Now that you have the understanding needed to write a regex, let's try out some examples together. Let's see how we can extract the phone numbers within this document. First, we want to match the first part of a number, which is the first 3 digits. To match any number from 0 to 9, we can use range in brackets 0 to 9. So this is going to match any number from 0 to 9. Now we need a quantifier. We only want to match 3 numbers, so let's quantify it by 3. This is going to match every 3 numbers. After the first 3 numbers, we want to match a dash or a dot. Let's do that. Dash or dot. Remember that a dot has a special meaning, so we want to ignore that special meaning. We can use a backslash. So this matches the first 3 numbers followed by a dash or a dot. This is a good time to introduce grouping to make the regex more readable. I'm going to group this together. After the first 3 numbers, we also want to match 4 numbers. Let's do that by using ranges 0 to 9, and then we can quantify it by 4. After the 4 numbers, we also want to match a dash or a dot. Let's do that by putting it in a group. A dash or a dot. Escape character. Next, we want to match the last 4 numbers. Let's do that. We can use a range of 0 to 9 and we can quantify it 4. If you notice, we've only been able to match just 2 numbers, this and this. The last 2 numbers are excluded because a dot or a dash is missing after the first 3 numbers. We can resolve this by specifying that a dash or a dot should appear 0 or 1 time. This can be done by making use of a question mark after the group. This question mark will be applied to this group. We can also do the same for the second group. I hope you can see why grouping is good. We can easily apply a rule to a specific group. We now have all the 4 numbers extracted. We are going to replace the range with a short form, \d, which is for digits. The same for this part, \d for digits, \d for digits. So this is the short form. Now let's see how we can extract the email addresses. The first part of an email address before the @ symbol can be any characters from A to Z. Let's represent that, uppercase A to Z. A dot is also allowed. Remember that a dot is a meta character, so we have to use a backslash to ignore its special meaning. We also want to allow dash. So this matches any character from A to Z lowercase, A to Z uppercase, an underscore, a dot, a dash. Now we need to quantify this match. In our case, we want to match 1 or more characters. So we can specify the quantifier to be plus, which means 1 or more. The next part of an email is the @ symbol. Let's do that, @. After the @ symbol, we also want to match the next part, A to Z, A to Z. We also want to allow a number as part of the domain and dash. I'm assuming that the domain can contain numbers. We also need to specify a quantifier. This means at least 1 character is required after the @ symbol. In this part before the dots, we don't want underscore and dot. Now we need a dot, \dot. We are telling Regex to match just a dot and ignore the special meaning of dots. As you can see, it now matches the dots. Next, we need to match the part after a dot. This should be at least 1 character, A to Z, A to Z, and plus. So this is how we can extract all the emails in this document. Let's see how we can make use of the short forms in this regex. We can use \w to match all word characters. If you notice, we haven't really used the caret and the $sign. The caret ensures that the match starts at the very first character. Let's put a caret at the beginning. Now if I was to write another email, it won't match. As you can see, this email is not matching because the match is not at the beginning. If I put a $sign at the end, then this email will not match because it is not ending the line. Let me put a $sign. It works as expected. The next step is to make use of a regular expression in a programming language. Alright friends, I will be using Python to explain some practical use cases. You can still follow along even if you don't write Python. We need to import the built-in RE module. Import RE. Name equals ABC \n aka \string. Remember that a backslash followed by a character indicates a special form or is used to escape the meaning of a meta character. It turns out that Python also uses a backslash for the same purpose. For instance, this \n means a new line. The second backslash quotes means that this delimiter should be ignored. Let's say you want to match this string using regex. We need to write ABC. A backslash is a meta character. For us to match it, we need to escape its special meaning by using another backslash, backslash, then followed by NAKA. We are going to use Regex 101 to check if the regex works as expected. I want to copy the string, which is this. Great, there is a match. Now, if you want to represent this regex, you will still need to escape the two backslashes. Let's print the regex on the screen. Regex equals this. Print regex. Let's run the program. So the only way to arrive at the regex is to use two more slashes, backslashes. Now let's run the program again. The solution to this repetition is to use Python's raw string notation. We need to use R in front of the string, then we can remove the two slashes. In raw string, the backslash is not treated in any special way, so it is highly recommended that you stick to raw string when working with regex. In this part, we are going to see how we can utilize some functions available in the RE module to do matching. The match function is used to determine if the regex matches at the beginning of the string. This regex pattern is for email address. The content does not start with an email address, so it is not going to match. Results equals re.match. The first argument for the match function is the pattern, which is the same as the regex. Let's pass the regex pattern. The second argument is the string which we want to match. Let's pass the contents. Print results. If I was to run the program, the result will be none because an email is not present at the beginning of the string. Let's run the program. It returns none. Now let's put an email at the very beginning. I'm going to copy this email, then let's put it here. Now let's run the program again. As you can see, a match object is returned. On a match object, there is a couple of methods available. Print results dot group, print results dot start, print results dot end. The group method returns the string matched by regex. We also have start and end. Let's run the program to see the output. Hello should be on a new line. Let's do that. Now we can run the program again. We have the matched string, which is the email address. The matched string starts at index 0 and ends at index 24. The third argument you can pass to the match function is the compilation flag. With the flags, you can modify some aspects of how regex works. re.ignore case. We are telling regex to do case-insensitive match. The search function looks for the first location where the regex produces a match and returns a match, re.search. If no match is found, it returns none. Let me remove the email at the start of the string. Now for the search, we can pass the pattern, the string, and the flags. So let's run the program to see what happens. As you can see, only the first match was returned, mail.readonray@gmail.com. The start index is 98, the end index is 122. Next, we have the find all function. This returns a list of non-overlapping matches in the string. So the expected output should be a list containing all these email addresses. Let's print the list on the screen. Print results. Now let's run the program to see the outputs. We have all the emails in a list. We also have the sub function, sub. The sub replaces every occurrence of a pattern with a string or the result of a function. We can pass a pattern, a replacement, a string, and we want to replace the emails with NA, not available. Also, we can pass the string, which is the content. The result should be a string with the email addresses replaced. Let's run the program to see the outputs. We have the email addresses replaced. There are some other functions and methods available. I only selected the most important ones from the documentation, so you may want to check the doc for the rest. Don't forget to subscribe, like, comment, and share. Thanks.